Hi children, we continue with our fourth chapter, carbon and its compounds, and today's topic is the last topic of this chapter, soaps and detergents. First we will see the cleaning mechanism of soap. So under soaps and detergents, the first topic is cleaning mechanism of soaps. So what are soaps? In the previous class, we learned about saponification reaction, and I told you that saponification reaction is used for the manufacture of soap. Soaps are sodium or potassium salts of long chain carboxylic acids. Sodium or potassium salts of long chain carboxylic acid. The carboxylic acid which we learned is CH3 COOH. This is a short chain only, but there are carboxylic acids like C17H. So this is not soap, this is just a carboxylic acid. C17H35 COONA. Okay, so here the chain is long. We will write the chain as CH3, CH2, CH2, CH2. Like this the chain goes on, and finally there will be CONA. And you can see that there is charge separation. So this end is known as ionic end. So this end of soap is known as ionic end. And this hydrocarbon chain, carbon chain, there is a carbon chain, carbon end, hydrocarbon end and an ionic end. So what are soaps? Soaps are sodium or potassium salts of long chain carboxylic acids. Okay, so this is a long chain carboxylic acid C17. 17 carbon atoms are there, 35 hydrogen atoms. So when you write it this way, in the condensed form CH3, CH2, CH2, a long chain will be there. So long chain carboxylic acid and sodium salt COONA. So actually there is a charge separation. So we call it as ionic end. Soap has an ionic end and a carbon hydrocarbon chain. Okay. Now most dirt is oily or greasy in nature, and oil or grease do not dissolve in water. Oil and grease do not dissolve in water. So that is the reason why we have to make use of soap to make those clothes clean. For the cleaning of those clothes we have to make use of soap. Otherwise if you just keep it in water, the water soluble dirt will dissolve in water and the clothes will be clean. But in case of oily and greasy dirt, soap is needed. We have to make use of soap to make those clothes clean. Soaps are long chain sodium or potassium salts of long chain carboxylic acid which has an ionic end and a hydrocarbon chain. Okay, the ionic end of soap. So soap has two ends. The ionic end which we call as hydrophilic end, water loving end. This is a water loving end. This will have an affinity towards water. Then the hydrocarbon chain, carbon chain. The hydrocarbon chain is hydrophobic, water hating. It has no affinity for water. So it has an affinity for oil only. This will have an affinity for oil. It is water hating. Okay, so sodium or potassium salts of long chain carboxylic acid. They are soaps. Soap has two ends. Ionic end COONA. That end is ionic end which is hydrophilic. Hydrophilic means water loving. It has an affinity towards water only. No affinity or love for oil or grease. Then the hydrocarbon chain. It is hydrophobic. It is water hating. It has no affinity for water. It has an affinity for oil, grease, etc. Then, so let it be an oil droplet on the cloth. So our cloth is kept in soap water, soap dissolved in water and the cloth is immersed in that. So this is the oil droplet. Now when soap is added, what happens is, so this is this structure. It resembles, it is the soap actually. What is it? This zigzag lines, CH2, CH2. Instead of writing CH2, CH2, we make use of the zigzag lines. Okay. Okay, so instead of writing CH3, CH2, 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 I told you one example C17H35. So instead of writing the CH3, CH2, CH2 like this, we represent it diagrammatically like this. So the oil droplet in the middle. So this is the soap molecule. This zigzag line with COO Na plus. So this is the soap. Actually this represents the soap. So it is surrounded by soap in all directions. So you can refer to the figure 4.12 in page number 74. Refer figure 4.12 in page number 74. You can see that the oil or the dirt is surrounded by soap molecules in all direction. The oil or greasy dirt in the center is surrounded by soap molecules. When you add soap to water, it contains thousands of soap molecules. So it is surrounded by soap molecules. It forms an emulsion in water. Emulsion in. How is the soap molecule oriented? This is the hydrocarbon chain. This zigzag line is the hydrocarbon chain, which is hydrophobic. It is hydrophobic. It is attracted towards the oil droplet, and this hydrophilic end is facing outside towards water. Okay, so the oil droplet is surrounded by soap molecules in all directions in such a way that the hydrophilic end, water loving end, CON, a polar end, that is ionic end, that is facing outside towards water, and the hydrocarbon chain, carbon chain which is hydrophobic, water hating but love towards oil, that will be oriented towards the oil droplet. Okay, so such a structure is known as a micelle. This structure is known as a micelle. Oil droplet in the center, surrounded by soap molecules in all the directions, in such a way that the hydrophobic end, the carbon chain is towards the oil or greasy dirt, and the hydrophilic end, ionic end, is facing outside. We call this structure as micelle. So the micelle helps in removing, dissolving the oil or greasy dirt from the cloth. It dissolves the oily or greasy dirt from the cloth, thereby forming an emulsion in water. Thus the clothes become clean. So this is the cleaning mechanism of soap. Soaps are sodium or potassium salts of long chain carboxylic acid. Soap has two ends, an ionic end, that is the COO minus Na plus, that end is ionic end, that is the ionic end. We call it as a hydrophilic end, which has a love for water, and the hydrocarbon chain, that is known as hydrophobic, which has love for oil, water hating but affinity for oil. So when soap is added to cloth containing oily or greasy dirt, the oil droplet will be surrounded by soap molecules in such a way that the hydrophobic end is oriented towards the oily dirt, and the hydrophilic end faces outside, thereby forming a structure known as micelle. Thus the oil droplet gets dissolved in soap and the cloth is washed clean. Okay, the micelle helps in removing the oil droplet from the surface of the cloth, thereby forming an emulsion in water, and the cloth is made clean. Okay, so that is the cleaning mechanism of soap. Now, what is the disadvantage of soap? Soap is not effective in hard water. Soap is not effective in hard water. Hard water contains what is hard water? The water that doesn't produce much lather with soap is known as hard water. Hard water contains calcium and magnesium salts. Water which contain calcium and magnesium salts are known as hard water. So when soap is added to water, hard water, soap will react with the calcium and magnesium salt forming a white precipitate known as scum. It forms a precipitate called scum. What is the primary function of the soap? What is the primary function of soap? To remove the dirt from the cloth. It has to act upon the dirt. So, instead of acting upon the dirt, when it is added to hard water, what soap does is, soap reacts with the calcium and magnesium salts which are present in hard water, thereby forming a precipitate called scum. Okay, so it will not be acting upon the dirt. So, it results in wastage of soap. A large amount of soap will be used up. It will not produce lather. So, we will make use of a large amount of soap. Finally, when all the calcium and magnesium salt, calcium or magnesium salt present in hard water is removed as precipitate. After removing all the calcium and magnesium salts present in hard water, soap will start to act on the dirt. So, that result in wastage of large amount of soap. So, that is a disadvantage of soap. It is not effective in hard water. Soap is not effective in hard water. Hard water is that which does not form enough lather with soap. It contains either calcium or magnesium salts. So, when soap is added to hard water, instead of acting upon the dirt, soap acts on the calcium and magnesium salts present in hard water, forming a precipitate called scum. This leads to wastage of soap. The first, soap will be acting on the calcium and magnesium salt producing white precipitate. Only when all these calcium or magnesium salts are removed from water as precipitate, it will be acting upon the dirt. So, that results in wastage of soap. So, this problem can be overcome by making use of another class of compounds known as detergents. Detergents are ammonium or sulfonate salts of long chain carboxylic acids. So, what are soaps? Soaps are sodium or potassium salts of long chain carboxylic acid. Detergents are ammonium or sulfonate salts of long chain carboxylic acid. So, they do not form precipitate with the calcium and magnesium ions present in hard water. The advantage is that they do not form charged ends of these detergents. They do not produce precipitate with calcium and magnesium ions present in hard water. So, they can be effectively used in hard water also. Detergents are used in the manufacture of cleaning products like shampoos. Okay. So, that is about detergents. I hope you understood this. Soaps are not effective in hard water because they react, instead of acting upon the dirt, when soap is added to hard water, it reacts with the calcium and magnesium, calcium or magnesium salts which present in hard water to form precipitate called scum. So, this leads to wastage of soap. So, this is overcome by making use of another class of compounds known as detergents. Detergents are ammonium or sulfonate salts of long chain carboxylic acids, and they do not form precipitate with this calcium and magnesium ions present in hard water. So, they are effectively used in hard water also. Okay. So, now we will see the differences between soaps and detergents. First one, sodium or potassium salts of soaps are sodium or potassium salts of long chain carboxylic acids. Detergents are ammonium or sulfonate salts of long chain carboxylic acids. Second difference is soaps are not effective in hard water. Not effective in hard water. What about detergents? Detergents can be effectively used in hard water. Effective in hard water. Third difference is soaps are biodegradable, but detergents are non-biodegradable. That means they may cause pollution. So it has certain advantages, but this is a disadvantage. It is non-biodegradable. Okay. So what are the differences? An important question. Differentiate between soaps and detergent. Soaps are sodium or potassium salts of long chain carboxylic acids, whereas detergents are ammonium or sulfonate salts of long chain carboxylic acids. Second difference, soaps are not effective in hard water. Soaps are not effective in hard water, but detergents are effective in hard water. When soaps are biodegradable, whereas detergents are non-biodegradable. So soaps do not cause pollution, but detergents may cause pollution. Okay. So that much about soaps and detergents. Please don't forget to learn figure 4.12, formation of micelle. That diagram is clearly given. Neat diagram is given in your textbook, where the oil droplet is surrounded by soap molecules in all the directions, forming a micelle, where the hydrophobic end is towards the oil droplet and the hydrophilic end, water loving end, is facing outward. That structure with oil in the center and surrounded by soap molecules in all the directions is known as micelle. So micelle helps in removing the oil droplet from the cloth, making it clean. Okay. So with that, our chapter carbon and its compounds is over. Thank you, children.